Okay, in this video, we are going to multiply and divide integers using number line models. Okay, you will need your integer model notes as we go through this video. If you do not have the notes page, then you will need to go ahead and just put this on notebook paper. Please stop the video as needed so that you can record all of the proper notes, fill out your sheet, your notes page. If I'm going too fast, just pause the video or rewind it as needed. Okay, the first problem that we're going to model is 4 times 3. What exactly does it mean? Well, if you've already watched the integer chips video, then you know that the 4 represents the number of groups. We want 4 groups. And the 3 represents the size of the groups. Size of groups. Since we are actually going to be modeling on a number line, the size of the groups represents how many units are in a hop. So if you'll recall back in elementary school, you used number lines to model multiplication. You also used it when you were learning multiplication by skip counting. You used it for skip counting. And you would skip count and you would make hops, and each hop was a certain size. So the size of our groups, you can also think of it as the size of the hops. As the size of hops. So what exactly does this particular problem mean? It means that we want 4 groups or hops or jumps, if you want to think of it as jumps, of 3 positive, oops, that's a 3, units. Or you could think of it as 3 positive steps. So let's go ahead and model. On the number line, just as with combining integers, you're always going to start at 0. So I'm going to place a dot at 0. And I want to jump or hop 3 positive units. So I'm going to make 1 hop or 1 jump, 3 positive units. I need to make 4 of those. So this was our first jump. I'm going to make the second jump, also 3 units, 3 positive units. Make my third jump, and then make my 4th jump. Each jump, as you can see, is 3 units. And we ended at 12. So our answer is 12. So 4 times 3 equals 12. You're going to do the same thing if you're taking 4 times negative 3, 4 groups of negative 3. So what does it mean? It means 4 groups or hops or jumps, whichever you prefer, of 3 negative units. So every hop or every jump we make is going to be 3 negative units. So again, start at 0. I'm going to make my first jump 3 negative units. My second jump is also going to be 3 negative units. I'll make another jump of 3 negative units and a final jump of 3 negative units. And where do we end? We end at negative 12. That's our end point. Okay, let's keep hopping here, or jumping. Now we have negative 4 times 3. Now remember, this first number is the number of groups. And can we have negative groups? No, we cannot have negative groups. So just like with the integer chips, there's 2 different things you can do. The first thing is you could use the commutative property. As you will recall, the commutative property means to change the order. Whenever you're adding or multiplying, which is what we're doing here, we're multiplying, you can change the order of your factors and it will not change your outcome. So instead of writing negative 4 times 3, I can rewrite that as 3 times negative 4, which would mean 3 groups of negative 4. And that would work because we want positive groups, not negative groups. So then you would model this just like we did on our previous example. The other way to do this is to take out this negative because it means the opposite. So think of it as being the opposite of 4 times 3. Okay, so we want 4 groups, but instead of them being positive 3 jumps each, we want them to be, well, not jumps, but units. We want them to be negative 3. So we're going to write this as, and I'm going to abbreviate here, the opposite of 4 groups or 4 jumps or 4 hops of 3, which would be four hops, it's H, or jumps of a negative 3, 3 negatives. So we start at 0, and we want 4 hops of negative 3. So it's 3 negatives, 3 more negatives, 3 more negatives, 3 more negatives. And we end at negative 12. So negative 4 times 3 equals negative 12. Our last example is negative 4 times negative 3. Okay, you cannot use the commutative property because when you switch it, it would be negative 3 times negative 4, and you would still have a negative number of groups, which we can't do. So we're going to do what we did above here, and we're going to take the opposite. We're going to take out this negative from our number of groups, and we're going to call it the opposite of, and then in parentheses, 4 groups of negative 3. So what does it mean? It means the opposite, abbreviate there, of 4 groups or 4 hops or 4 jumps of 3 negatives, which would be four hops or jumps or groups of, and the opposite of negative 3 is a positive 3. So when we do this, we start at 0, and each of our hops are going to have 3 positive units, so we're going to go to the right. There's 1 hop, 2 hops, 3 hops, 4 hops. Each hop, you can count, is 3 units. And we end up, our endpoint is at a positive 12. So negative 4 times negative 3 equals a positive 12, or just 12. Now let's talk about division. Excuse me. Division is the opposite of multiplication. Okay, multiplication, we multiply the number of groups times the size of the groups to get our total, our endpoint. This time in division, we're given the endpoint. So the 12 is our endpoint. It's where we need to end up at. And the 3 is going to be your number of groups, or number of hops or jumps. So we're going to take 3 hops and end up at 12. So what are we looking for? We're looking for the size of our groups, or the size of our jumps. Okay, so what does it mean? It means that we're taking our 12 positive, and we're going to divide it, to split it. Divide or split into 3 groups or hops or jumps. And we're looking for our size of jumps. All right, here we go. We're going to start at 0 again, and our endpoint is 12. So we're going from 0 all the way over to 12. And we need to split this equally into 3 groups. So when you split it equally into 3 groups, it's going to look like this. And the size of each group is 4 positives. So our answer is 4. 12 divided by 3 equals 4. Now we're going to do the same thing, except for our endpoint is negative 12. So this is going to be 12 negatives split or divided into 3 groups. And again, we're looking for the size of the jumps. So here's our 0. Our endpoint is right here at negative 12. So from 0 to negative 12, whoops, that wasn't very good. We want to split this into 3 equal groups. So there's 1. And now you have 3 groups, and each group size is 1, 2, 3, 4 negatives. 1, 2, 3, 4 negatives. 1, 2, 3, 4 negatives. So negative 12 divided by 3 equals a negative 4.